Hello everyone, welcome to Diksha Karnataka YouTube channel and in the COMEDK 15 most repeated PYQs. Today I am going to discuss ray optics and wave optics. Both chapters are important and can be tricky if you are not prepared enough for these two chapters. So obviously how to understand about any examination is by looking into their PYQs, right? So same for COMEDK as well. So for COMEDK also you have to learn about the exam by looking into the previous year questions. So let's start. So first question is, a ray of light is incident normally on the prism n equals to 3/2 immersed in a liquid as shown in the figure. The largest value or the angle largest value of the angle alpha so that the ray is totally reflected at the face AC is 30 degrees. So this angle is given as 30 degrees when the ray is totally internally reflected. Ray is totally internally reflected means when the ray falls on this, obviously this is a normal surface, so no ray actually there is no deviation happening over here. The ray is falling directly on this surface, and after falling this surface the ray directly passes like this. Okay, so this is the path of the ray inside the prism. They ask you the refractive index of the liquid is, so this is a liquid of say refractive index given by n, okay, and the refractive index of the prism is given here 3/2. Okay, now how to find this question? Obviously for that we have to find this angle of incidence I or angle of reflection, which is also same as I. Why both are same? Because they are following law of reflection, and law of reflection says that angle of incidence should be equals to angle of reflection. So that's why these two angles has to be same. Now this angle is alpha. Now after this ray actually totally internally reflected, as you can see this is a right angle prism. This is a right angle prism, so that means after it comes from here this angle will also be 90 degrees. Okay, this angle will also be 90 degrees. Now this angle is 90 degrees, this angle is 30 degrees. So if you take the smaller triangle, what this angle will be? This angle will be 90 minus 30, that is 60 degrees. Okay, now again this is a normal, that means this angle is 90 degrees. So this total angle is 90, out of that this small angle is 60. So what will be this angle? This angle will be 90 minus 60, that is 30 degrees. So we have calculated the internal angle. Okay, now the extreme case, what is the extreme case in total internal reflection? The extreme case is when the ray actually passes directly through this medium. Okay, so that is the critical case. So any small change, small increase in the critical angle, okay, will give you total internal reflection. So even 0.1 degree increase from the critical angle will give rise to total internal reflection. So for all practical purposes we will take this angle as our critical angle. So this is our critical angle. That means what is theta c? Theta c is given by 30 degrees, or critical angle is given by 30 degrees. So if you know the critical angle, you know that this medium is 3/2. The refractive index of this medium is 3/2. 3/2 sine theta c equals to refractive index of the surrounding medium into sine 90. But sine 90 is 1, so we can say that so we will say that this is equals to 1, right? 1 into n, that is n. So we are trying to find this value n, so let us find that. So n equals to 3/2 into sine theta c. What is sine theta c? Sine theta c is sine 30. We have already found that. Actually it is slightly less than 30, but for all practical purposes, as I mentioned, we can take this as 30 degrees, so it will be 1/2, so that is 3/4. So the refractive index of the medium must be 3/4. So option B is correct answer for this question. Very interesting, right? Completely different than what you are used to for KCET exam. So now next question is, focal length of convex lens is 100 centimeter and focal length of the concave lens is 8 centimeter. Find the magnification of the given combination of the lenses if object is placed at point O. So here if you see that here object is placed at O, this distance is 50 centimeter, this distance is 90 centimeter. Now one major problem with this is that the lenses are not in contact. Okay, so you cannot directly find the equivalent focal length. Now you can do that, you can find equivalent focal length, that is not an issue, but that then you have to find where the final lens combination is, so that might be slightly tricky. So how to tackle this kind of questions? Obviously we will take the image formed by the first lens. So if the ray is falling here, okay, the focal length of this one is given 100, focal length of this one is given 8, and they ask you what is the final magnification. Okay, so how can we find that? So we have to find the original image formed by the first one, and one important formula, important shortcut formula that you need to remember, that the magnification for a lens is given by f divided by f plus u. Okay, the derivation is very easy, you can try and find that why this formula is like this. Okay, but this is a very handy formula, especially if you are preparing for COMEDK. This formula is very important. It is not so important for KCET, never came, but for COMEDK students this formula is one of the most important formula. So for focal length, for the first lens, what is the magnification? Let us calculate. So focal length is given by 100 centimeter, for convex it is positive, so 100, and u is here 50 centimeter, that means it must be negative 50. Okay, u is always negative, so it will be 100 by 50. So the magnification because of the lens number 1 is 2. If we can somehow find the magnification due to the second lens, then the total magnification will be magnification of lens number 1 into magnification of lens number 2. Okay, so that is how we should approach this problem. This is the shortcut way to solve such kind of questions. Now the one problem is that we do not know the u for the second lens, because why? First lens will form an image somewhere, and that image will be behave as an object for the second lens. Now the focal length is 100 centimeter, the object distance is 50 centimeter. So this is forming actually a virtual image. So this is a convex lens, length is less than focal length. That means if the distance is less than focal length, what happens? This forms a virtual image which is actually behind the lens. So this distance we have to find for the second lens. Okay, if we can find this distance, that will give us the new u for the second lens. That is our target to calculate. So this distance we have to calculate. So how to do that? Obviously we will use lens equation in the first lens. So lens equation in the first lens gives us 1 by v minus 1 by u equals to 1 by f, or 1 by v equals to 1 by u plus 1 by f. Okay, this goes to other side, becomes positive. So we get 1 by v equals to uf by u plus f, or v equals to uf by u plus f. This is again the formula that you can remember, and that will also be very, very helpful in COMEDK. Okay, so let us find the v value. U is minus 50. Okay, f is 100 divided by minus 50 plus 100. So it will be 2 into minus 50, that is minus 100. You can remember one more thing. Okay, one more shortcut. Instead of doing all this, if you remember this formula, to calculate magnification, then v is always magnification into u. V is always magnification into u. So magnification we have calculated 2, u is minus 50. Okay, so the v is minus 100. V will be minus 100 for the lens number 1. So this is V1. Okay, this is V1. Now what is the object distance for the second lens then? What is the object distance? First lens part is done. So what is the object distance for the second lens? The object distance for the second lens U2 will be obviously this 90 and this 100, but they are both of them will be negative. Okay, so minus 100 minus 90, that is minus 190. Why both are negative? Because both distances are on the left hand side of this lens. Both distances are on the left hand side of this lens, so that means this distance is also negative. The final image which is forming even beyond this lens, that is also negative. So both negative adds and it becomes minus 190. Now again we know the 190. Now we do not need to calculate V anymore. We can directly calculate the magnification M2, which is given by F2 divided by F2 plus U2. Okay, here everything is 1 and this one is U1. This distance is U1. Okay, so now let's put that values. F2 is 8 centimeter, but it is a concave lens. So concave, for concave surfaces it will always be negative, be it mirror or be it lens. F2 is minus 190 plus minus 8. So we get minus will cancel, all the minuses, you get 8 by 198. So this is the magnification due to the second lens. Now what is the total magnification? Total magnification is given by magnification of the individual lenses, multiplication of the magnification due to individual lenses. So M1 is 2, M2 is 8 by 198. Okay, now this can be little tricky. If you don't know how to simplify, you can use the on-screen calculator which is available in COMEDK, or what you can do, 2 into 8 by this 198 can be approximately taken as 200. So you can cancel that by 2 and you get 0.08. If you see the option, 0.08 is the correct answer for this question. Okay, now this method is obviously particularly applicable for this kind of combination of lenses. Based on different situation, we will apply different formulas, but this is one of the very basic formula in COMEDK. Let's move on to another question. A ray of light strikes a silvered surface inclined to another one at an angle of 90 degrees. Then the reflected ray will turn through. So if you see that here, this ray is coming over here, this ray is falling over here, and once it is falling over here, okay, where it will go? It will straight away go in this direction. Will it come in this in the direction of the second mirror? No. So this is just a trick question. Okay, the main thing they are trying to explain you that the ray will be directly reversed. So what is the angle between incident ray and reflected ray? It will be 180 degree. Okay, so the incident ray and the reflected ray will make an angle 180 degrees, nothing else. Very simple, easy question. Easy questions are there, and in COMEDK, if the question is easy, it is very easy. Okay, if the question is medium, it can be difficult. Okay, so medium questions and difficult questions are difficult, but easy questions are really easy. The size of the image of an object which is at infinity as formed by a convex lens of focal length 30 centimeter is 2 centimeter. If a concave lens of focal length 20 centimeter is placed between the convex lens and the image at the distance of 26 centimeter from the convex lens, the new size of the image is. So this is again, first is we have a concave lens, convex lens, and we have a concave lens. Okay, and it says that the ray which is coming from infinity. Okay, so focal length, if the parallel ray falls on a lens, where does it converge? It always converges at the focal length. So focal length of the lens is given as 30 centimeter. So it will, all of them will converge at 30 centimeter. Okay, but in between we have a 20 centimeter distance, we have a concave lens. Okay, so the focal length of the convex lens is 30 centimeter. This is 30. But in between we have, at the distance 20 centimeter, we have So what will happen, this ray will come and fall on this lens, and after falling on this it will even go further and it will come over here. So what is the u? So this distance will act as a virtual distance. This is something new we have not studied in our textbook so far. This is called virtual distance, virtual object. So this object is in reality does not exist, but when you keep a lens, actually it used to be going in this direction. So in this particular case, u is positive. So this u for the second lens, this u is positive. What is the value of u here? Value of u is 30 minus 20, which is 10 centimeter. So this is a particular case where u is positive. So u is positive. Okay, now we know the focal length of the image at a distance of 26 centimeter from the convex lens. Sorry, small mistake here. The focal length of the lens is, focal length of this lens is 20. The distance is not, this distance is not 20, this is 26. This distance is 26. Okay, this distance is 26 centimeter, sorry. This distance is 26 centimeter. Okay, that means the object distance for the second one is not 10, but it will be only 4 centimeter. So u is 4 centimeter, focal length is 20 centimeter. What is the magnification? Again the same formula, magnification is f by u plus f. Now for a concave lens, focal length is negative, so minus 20. But this is a very particular case where u is positive, because u is on the right hand side. Okay, so that's what you have to understand in this problem. Okay, minus 20. So m is minus 20 by minus 16. Minus cancels and you get 5 by 4. So 5 by 4 is the magnification by the concave lens. Size of the original object was 2 centimeter, so this object was 2 centimeter long. So what will be the final image? Final image size will be, so final image size will be size of the object into magnification. So the first lens is actually given only to understand where this image is being formed. That's it. The first lens has no role to play in this problem. You don't need to apply any rules, any laws. Only thing that because the object is at infinity, so the final image will be forming at focus. That information is required from the first lens. Otherwise, we do not require the first lens. Okay, so h naught is given here 2 centimeter, and m we have calculated 5 by 4. So they cancels and we get 5 by 2, that is 2.5 centimeter. So the final image size will be 2.5 centimeter. Very easy. Again we use the same formula. Two beams of red and violet colors are made to pass separately through a prism of the prism angle 60 degrees in the position of minimum deviation. The angle of refraction will be 30 degrees for both the colors, greater for violet color, greater for red color, equal but not 30 degrees for both the colors. So first of all, at angle of minimum deviation, it is unique situation for all colors. Okay, at minimum deviation all colors give you same angle of minimum deviation, no matter what type of color you are using. Okay, you will get minimum angle of deviation for all colors will be same. Okay, angles, positions will be different, but angle of minimum deviation will be same for all colors. It is not property of the color, it is the property of a prism. So angle of minimum deviation, and it comes from geometry only, so angle of minimum deviation will be same for all the colors. Okay, so let's see. So we know that angle of prism is equals to 2r, twice the angle of refraction. Okay, so angle of refraction will be a by 2. So a by 2 means 60 by 2, that is 30 degrees. Okay, so 30 degree for both the colors will be the answer. Now next question, a ray of light falls on a transparent sphere with C center as shown in the figure. The ray emerges from the sphere parallel to the line AB. The refractive index of the sphere is. So again, as I mentioned, COMEDK questions are not always easy. So we can see here. Okay, here you can see that ray is falling on this sphere, and what happens here, it obviously refract. So this, if you take this is the normal, so ray of light will bend towards the normal and it will go straight, and then when it reaches over here, it emerges out as parallel to this base. So it emerges out as parallel to this base. This information is given in the question. So ray is traveling like this, traveling like this. Now how to solve this question? They ask you what is the refractive index of this medium, this glass. Outside is air. Okay, so how to solve it? First you have to remember that if you join the center with a point on the circle, okay, this is a property of circle applicable to sphere as well. So if you join it and extend it, it gives you a normal to the tangent. It gives you a normal to the tangent. That means this line acts as a normal. So let me make it a dotted line. Okay, let me make it a dotted line. Okay, so that means this actually acts as the normal. So if this angle you know, and if you can find out this angle, then you can find the refractive index. Okay, you can find the refractive index by either using Snell's law at this junction or Snell's law at this junction. Any one junction you can apply. Okay, in fact in this problem we have to apply Snell's law at both the junctions to find the correlation. Anyway, so now let us understand what is happening over here. If you observe, this is a radius, this is also a radius. That means this triangle, if you take the inside triangle, that is this triangle, okay, they are isosceles triangle. Isosceles triangle means this side is equals to this side. That means this angle must be equals to this angle. Okay, so if this angle is theta, then this angle will also be theta, because this is an isosceles triangle. Isosceles triangle means both sides are same. Okay, if both sides are same, what happens is that, so this is a triangle, this is an external angle, this is an external angle. So if this is an external angle, this is theta, this is theta, so this angle will be theta plus theta, that is 2 theta. So if you remember the external angle of a triangle, external angle of a triangle is, so external angle of a triangle for any triangle, suppose this is alpha, this is beta, okay, external angle is alpha plus beta. Okay, this is valid for any triangle and any angles. Okay, if you take this angle as beta and this is gamma, then if you extend this side, okay, and this side, this angle will be sum of the internal angles alpha plus gamma. Okay, this is a property of a triangle. Okay, not this angle, sorry, not this angle, external triangle. So external angle means this angle. So this angle will be alpha plus gamma. Okay, and this is valid for all triangles, for all external angles. So this is the internal angles, this is the external angle. So external angle is sum of opposite internal angles. External angle equals to sum of opposite internal angles. That means except this angle, whatever angles are there, that sum will be given you by sum of these two angles, right? This is very old school geometry. You have done the proof in geometry, right? Now we have what we have achieved, that this angle is theta, this angle is theta, this angle is 2 theta. Now also from geometry you can say that this line and this line are parallel. Why parallel? Because it is given in the question that the emergent ray is parallel to the line AB. So this line AB and they are parallel. So if they are parallel, what you can say is that this is the bisector. This line is the bisector. So two parallel lines, this is the bisector. So this angle must be equals to this angle. Okay, alternate angle. So this not alternate angle, similar angle. So this angle must be equals to this angle. So this angle is 2 theta. So this angle will also be 2 theta. Okay, so this angle is theta, so this angle will be 2 theta. So this is the start. Now let us find the angle theta. Once we calculate the angle theta, then we will be able to solve this question in no time. So geometry is first. So in such cases, some cases you need to apply some geometry knowledge, okay, a lot of geometry knowledge, and once you have simplified the question as quickly as possible, then the remaining portion is just apply laws. So what is the first law we will apply? So refractive index of air into angle of incidence, sine of the angle of incidence, that is sine 60, equals to refractive index of the glass medium into sine of the refracted angle, right? This is Snell's law. This is, say, equation number 1. Now we will applying, this is at point A, at A. Now suppose this point is given by point, say, P. This point is P, okay? Now we will apply the same thing at P. So at P, what we get? P inside, first angle is theta, incident angle is theta, refractive index is n, so n sine theta equals to 1 into sine 2 theta. Now do not try to simplify this, that will take longer. What we will do, we will compare equation 1 and 2 for value n sine theta. So if you compare, n sine theta is 60 degrees, sine 60 degrees, so we can write sine 60 degrees, okay, equals to sine 2 theta. How did I get it? Comparing one and 2. Okay, comparing 1 and 2, we get sine 60 is equal to sine 2 theta. So 2 theta equals to 60 degrees, or theta equals to 30 degrees. So 30 degree angle is now calculated. So once we have calculated this angle, now just put that in the first equation from equation 1. Okay, sine 60 equals to n sine 30. Okay, so sine 60 is root 3 by 2 equals to n, sine 30 is half, so 2 cancels and we get n equals to root 3. Okay, simple. So n equals to root 3 is the correct answer. Okay, again, not super easy but not super difficult as well. If you figure out the geometry and use this simple trick, you can solve it without any difficulty. Next, a thin convex lens made of crown glass n equals to 3 by 2 has focal length f. When it is immersed in two different liquids having refractive indices 4 by 3 and 5 by 3, it has the focal lengths f1 and f2 respectively. The correct relationship between focal lengths is, now here the focal length of the lens is given by 3 by 2, which is not approximately, which is equals to 1.5. Okay, now when it is immersed in a liquid of refractive index 4 by 3, okay, so what is this is lens. Okay, so for refractive index of lens. Okay, now what is the refractive index of the first liquid number 1? That is 4 by 3, which is 1.33. Okay, obviously this refractive index is greater than 1, greater than air, but it is less than that of lens. So n1 is less than that of n lens. So definitely the lens which was convex will still remain convex. Understand this logic. You can do mathematics, but that will take longer time to solve. But if you understand the physics behind this question, you can solve this question in less than 1 minute. Okay, so because the refractive index of the medium, because the refractive index of the surrounding medium is less than, so one lens put in some liquid. Okay, so refractive index of the liquid is less than that of the focal lens. Then what? Then it will still remain convex. The focal length will still remain convex. Okay, but the focal length will increase. Focal length will increase. Okay, if this is less than 1, then the focal length will decrease. Okay, but here the refractive index is greater than 1, so focal length will definitely increase. Okay, remember that. comma n1 is greater than 1. So if these conditions are satisfied, then it will still remain convex, but focal length will increase. So f1 is more than f. f1 is more than f, so this condition is supposed to be most likely to be correct. Let's check the second thing. Okay, in two different liquids having refractive indices 4/3 and 5/3. Now let's check the second liquid. Second liquid is 5/3. 5/3 means it will be approximately 1.23. 2/3 means 6, 7. Okay, so refractive index of the second medium is here 1.67. Now who is greater? Obviously second refractive index is greater than that of the lens. Okay, this is greater than that of the lens. So that means if the outside refractive index is more than that of the lens, the nature of the lens changes. If the outside refractive index is more than that of the inside of the lens, then the nature of the lens changes. A convex lens behaves like a concave lens. A concave lens behaves like a convex lens. Okay, so in this case the convex lens will behave like a concave lens, so focal length will be negative. Okay, so f1 greater than f and f2 becomes negative is the correct answer. Okay, so understand this. You can solve it using lens maker equation as well. If you get time, if you get some free time, you can solve the same question using lens maker's equation, which will take a good 3-4 minutes to solve, but that is a sure shot way. If you want to use logic, if you want to understand the question, then this is the way to solve the same question using logic without any calculation. Okay, a concave mirror of focal length f produces a real image n times the size of the object. The distance of the object from the mirror is. Again, the real image it is given, and here it is given concave mirror. So mirror equation is given by 1/v minus plus 1/u equals to 1/f. Okay, or 1/v equals to 1/f minus 1/u, or uf u minus f, or u/v equals to u minus f by uf. So we get, from this we get, sorry, one mistake, this u will not be there because this u we have taken and divided. Okay, so we get v upon u equals to f by u minus f. Okay, so now what is the magnification? Magnification is minus v by u for mirrors, plus v by u for lenses, minus v by u for mirrors. So this is important. So from here you can say that magnification is given by minus f by u minus f. Now in this case it is mentioned in the concave mirror the image is real and n times the size of the object. So that means magnification here is minus n. Real images gives negative magnification because it is inverted always. So that is given here as minus f by f minus u. Okay, so minus minus cancels. Now do the cross multiplication. Nf minus nu. I think there should be one mistake. You have to use the sign convention of the mirrors as well. You have to use the sign convention of the mirrors as well. For concave mirror, focal length is negative. Okay, and object is always negative. So you get here minus f by u minus f. Okay, minus f by u minus f. The mistake I have made is that minus f by u minus f, so it will be minus f by u minus f. Okay, you can use the sign convention, eventually it will give you the same value. So minus n equals to minus f by u minus f, minus minus cancels, and you get minus f by minus u plus f. Eventually you will get the same thing, that is f by u minus f, same thing. Okay, if you take the sign convention of f and u or not, that is same. Now do the cross multiplication. Nu minus nf equals to F, or Nu equals to F plus Nf. So if you take F common, you get N plus 1. So U equals to N plus 1 into F by N. So correct answer is this one. Okay, not difficult, not easy as well. And if you want to solve more questions from every chapter and obviously prepare well for COMEDK, then COMEDK KC30 batch already started, live orientation already happened. You might see that in YouTube later time. So the batch is already live and the price of the batch is 2499. Already many students, more than 150 students have already registered, and more are already on the way. And if you want to be part of that excellent batch, then wait not, please join the batch today. The link of joining the batch is given in the description section of this video. Click there and purchase the batch and join the batch right now. Okay, so the price of the batch is 2499 only. Don't wait, you might lose a chance to get a seat in COMEDK if you are not prepared for COMEDK exam properly. Now let's move on. I naught is the intensity of the principal maximum in the single slit diffraction pattern. Then what will be the intensity when the slit width is doubled? So remember that the intensity of light is proportional to the slit width. Okay, square of the slit width. So if you increase the slit width, the intensity will be more, and here we have double the intensity, so it will be simply 4 times, so it will be 4 I naught. So the intensity will be 4 I naught. So if you double the size of the screen, the new intensity will be proportional to this. The proportionality constant is same, so that means it will be equals to 4 I naught. So if you double it, it will be 4 times. If you half it, it will be 1/4 time. Okay, so again these concepts generally do not come in KCET if you are watching. Two sources of light of wavelength 2500 angstrom and 3500 angstroms are used in Young's double slit experiment simultaneously. Which orders of fringes of two wavelength patterns coincide? So you have to find which orders are coinciding. Now we know that suppose nth of the first light, which is n lambda 1 d by d equals to m lambda 2 d by d. Okay, this is very common formula. Okay, yn or the location of nth bright fringe is given by n lambda d by d. Right, this is the location of the nth bright fringe. Now if you compare, obviously dd cancels and you get n lambda 1 equals to m lambda 2, or n by m equals to lambda 2 by lambda 1. So what is lambda 2? Lambda 2 is 3500 and lambda 1 is 2500. So if you cancel 0 0 0 0 5 7, so n by m equals to 7 by 5. So for n will be 7, m will be 5. Okay, exactly relationship is like this. So n value is 7, m value is 5. That's why it is 7 by 5. So 7th of the first, 7, this is first, right? This is first, this is second, this is first, this is second. So 7th of the first and 5th of the second. 7th order of the first and 5th order of the second will coincide. Now next, unpolarized light of intensity I passes through an ideal polarizer A. Another identical polarizer B is placed behind A. Okay, so it is placed behind A. The intensity of light beyond B is found to be I by 2. Now another identical polarizer C is placed between A and B. Okay, so another identical polarizer C is placed between A and B. The intensity beyond B is now found to be I by 8. The angle between polarizer A and C is. So basically what we have a polarizer A, we have a polarizer B. The unpolarized light is I. The unpolarized light is I. So when an unpolarized light passes through a polarizer, the intensity becomes half. In the case number 1, okay, we found the intensity out of B is also I by 2. intensity out of B also I by 2. That means the angle between A and B, the angle between A and B is actually 0 degree. So they are parallel. First polarizer is polarizing I by 2, the angle between them is 0. So that means the second polarizer is also giving a angle of same value, right? So that's why it is I by 2. Now what happens is that between A and B you have placed another polarizer of C, okay, say at an angle theta. You have kept an angle theta. Okay, so what is the angle between A and B? Angle between A and B is theta. What is the angle between A and C, sorry? What is the angle between C and B? Angle between C and B is also theta. Both angles will be theta. One will be plus theta, another will be minus theta. Does not matter. Okay, so if you take this angle as plus theta, the other angle will be minus theta. But the law that we are going to apply, sign of the angle does not matter. Suppose now, as I mentioned, the first light is coming over here is I. The light which is falling over here is I by 2. Suppose the light which is coming intermediate, that light is I dash. Okay, the final light found out to be I by 8. Now they ask you what is this angle theta. So both polarizer will have the same angle theta. Understand the first logic, because first polarizer is already doing the polarization I by 2. The second polarizer is also giving you I by 2. That means the angle between them is 0. Okay, now we will be applying Malus law. So first case angle is theta, incident light is I by 2, final light will be given by I dash will be given by I by 2 cos square theta. Okay, this is the first light. Now for the polarizer B, what will be the case? For polarizer B, the final output is given as I by 8, and that is equals to I dash cos square theta, another cos square theta. Okay, so that means we have to put this I dash value over here. We get I by 2 cos square theta into cos square theta. So that means we get I by 8 equals to I by 2 cos to the power 4 theta. So we get I by 2, I cancels, we get 1 by 4. So cos to the power 4 theta equals to 1 by 4, or cos theta equal to 1 by root 2. Okay, 1 by 4 square root is 2, and then square root of 2 is root 2, so it will be 1 by root 2. Okay, so we get theta equals to 45 degrees. Okay, so theta is 45 degrees. 1 by root 2 means 45 degree. So correct answer is option C. Now next, the slits in Young's double slit experiment are illuminated by light of wavelength 600 angstrom. If the path difference at the central bright fringe is 0, what is the path difference for light in the slits at fourth bright fringe? So path difference for bright fringe is integer multiple of lambda. Okay, for dark fringe it is odd multiple, okay, but it has to be 2n minus 1 lambda by 2. So here it is simply for bright fringe, it is simply n is equal to n lambda. Okay, n can be 0, 1, 2, 3, 4. For 0, path difference is 0 given. Okay, so you don't need to add or subtract anything. You just need to multiply 4 into the wavelength, which is given 6,000 angstrom. Angstrom means 10 to the power of minus 10. So it will be 24 into 10 to the power of minus 7, or 2.4 into 10 to the power of minus 6 meter. Okay, so correct answer is 2.4 into 10 to the power of minus 6 meters. Very simple, very easy question. Next, a parallel beam of monochromatic light of wavelength 600 nanometer passes through a single slit of 0.4 nanometer width. Angular divergence corresponding to the second order minimum would be. So second order minimum, so what is the angular divergence? Angular divergence means angle theta. Okay, angle theta is given by, so first of all, this is talking about diffraction. Okay, this is talking about single slit diffraction. Okay, so A sin theta equals to A sin theta equals to n lambda. This is the formula that we use for diffraction. Now for small angle theta, if the angle theta is very small, we know that A theta can be written as n lambda A theta can be written as n lambda. Okay, here we will assume the angle theta is small. Obviously, if you see the options also, it is given in radians, and this formula is only applicable when you are calculating theta in radians. So n is given here second order, okay, and the wavelength is given 600, okay, and then 600 nanometer means 10 to the power of minus 9 divided by A value, the slit width is given 0.4 millimeter. Millimeter means 10 to the power of minus 3. Okay, now let's simplify. We get this as 2 into 600 is 1200. 1200 divided by, okay, let's calculate that. These zeros let us cancel. 12 into 10 to the power of minus 7 divided by 4 into 10 to the power of minus 4. So that is 3 into 10 to the power of minus 3. So 3 into 10 to the power of minus 3. So correct answer obviously is 3 into 10 to the power of minus 3 radians. So this is the angular divergence. This is called angular divergence. This is the formula that you have to remember for diffraction. Diffraction based, angular divergence based questions are generally common in COMEDK. Total angular divergence is 2 theta. Here only angular divergence they have said, that is theta. Total angular divergence is 2 theta. Two light waves of intensities I1 and I2 having same frequency pass through same medium at a time in the same direction and interfere, the sum of the minimum and maximum intensity. So what is the maximum intensity when two lights interfere? The maximum intensity is I1 plus I2 plus 2 I1 I2 cos phi. Okay, cos phi is the difference in the phase difference between the two lights. Okay, obviously they are not in same phase, that is not said over here. So what about minimum phase? Minimum phase is I1 plus I2, again plus I2, but this one will be minus I1 I2 cos phi. So I1 I2 cos phi cancel. So if you add these two, okay, I max plus I mean will be 2 into I1 plus I2. Okay, so 2 into I1 plus I2 is the sum of the maximum and minimum interference intensities. Okay, this is always true. This is not only for this, for all type of interference we see this pattern. Next, to observe diffraction, the size of obstacles. This question is also asked in KCET. Should be lambda by 2, should be order of the wavelength. So we know that to observe diffraction, the slit width should be of the order of the wavelength. So this brings us to the end of this lecture, and if you are want to prepare for your KCET COMEDK exam, you are already saying I have prepared enough, I have studied all the textbook, but I need some questions from where I should practice. Then COMEDK rank booster test series, which is exclusively test series, okay, where you will get the tests and their solutions, video solutions. 12 full length paper. Full length paper means physics, chemistry, maths in one paper. One paper includes physics, 60 physics, 60 chemistry, 60 maths. 12 such full length paper you will get, and that price is only 999. Again, the classes started from today, the batch started from today. If you want to join, click on the link below. 12 tests you will get in time, okay, according to the schedule that we will share. Okay, so you will still have time. If you think that my preparation is well enough, I am prepared for KCET, I have prepared for other exams, JEE exams. So theory part I am solid, I just need some question practice. Then COMEDK test series is here only for 999. Join this and you will get the full lectures, full 12 full length papers along with their video solutions as well. Okay, this is the end of this lecture. I will see you in another lecture very soon. Till then, bye.